In this video, we will be diving deeper into the physical properties of materials. A material consists of two elements, the texture image and the physical properties that decide the drape of the material in 3D. To capture the physical properties, we use the Fabric Analyzer by Browseware, or FAB for short. Using the FAB, we run several tests on a physical swatch to accurately capture the material's physical properties. The physics dialog box is where we can see all of the captured values, including the fabric's thickness, stretch, bend, and shear values. Additionally, we enter in a few values manually, including the mass, which has an effect on the drape. For additional information on the actual testing process, refer to the FAB manual on the Help Center. We will be editing individual parameters in the physics dialog box to help visualize how each testing result can impact the final fabric drape. This is just for theoretical purposes. We always recommend using the FAB to acquire the testing results for accurate representation of the physical fabric. Now let's look at what the results mean for the drape of the material. Mass is the grams per meter squared weight of the fabric. As this value is increased, the fabric becomes heavier. Friction determines the grip of the fabric to the avatar. We typically leave this value at the default value of 0.2. As this value is increased, the more likely it is to grip onto the avatar. Thickness determines the visual thickness of the fabric in the 3D window. Moving on to the bend, the value entered for the width and length determines the fabric's stiffness. The lower this value is, the more likely the fabric is to drape. Typically, the lowest value for this field is 5, with 2000 being an extremely stiff fabric like a treated denim. The next value is the stretch of the fabric. This determines the ability of the fabric to stretch. The lower this value is, the more willing the fabric is to stretch. To best illustrate the effect of the value, we'll use the 3D tension map. This tool shows us the effect or force needed to stretch the material, ranging from comfortably stretching in white to green to deep red, indicating we are approaching the breaking elongation. Here we see a low stretch value, such as a knit spandex fabric, versus a fabric with a high value like a cotton woven. Also related to the stretch is the stretch linearity, which determines the resistance variability of the fabric as it is stretched. Fabrics with a low value begin resisting sooner, whereas fabrics with a high value stretch further before they begin to resist. The last two values related to stretch are the shear and shear linearity. These values are identical to the stretch and stretch linearity, but they're related to the bias of the fabric. The next value is shrink. When this is selected, it determines the amount of shrink applied to the fabric. This can be used in examples where you know the pattern used will be shrunk post-wash. Next is the puffy firmness. This is related to creating a puffy fabric within the software. Specifically, this determines the density of the filling. Puffy effects are covered in a separate video. If you would like to learn more about puffy fabrics, refer to the Help Center. The last section to cover in the physics dialog box is the molded option. When this is enabled, the specified fabric is formed into the selected shape. This feature is most commonly used for bra creation. The effect of this is best seen in prepare mode. A reminder that we've adjusted individual parameters in the physics dialog box solely to help visualize how each testing result can impact the final fabric drape. We always recommend testing your physical fabric in the FAB to produce the most accurate testing data, and not to manually alter the fabric physics parameters. In this video, we've covered the basics of fabric physics. For more information, check out the Browseware Help Center.